Welcome to Study Loop.
This is chapter 37, problem number 6. You are the driver in a ship that goes towards the moon at a constant speed, and there is a racer passing you by. This is the problem, just to remind you. So in this problem, the proper time, T naught, is what the racer measures, actually, right? What the racer measures, because the racer, when it passes by you, from the moment that she passes by you to the time that you're interested in, racer is it's in its position, right, in the ship. So in part A, we are trying to figure out this proper time that the racer measures. So then actually T naught, the proper time, is going to be equal to time divided by the gamma factor, as you know. What we're given the distance from you to the racer at that moment. So it's actually x equals 1.2 times 10 to the power of 8 meters at that point. If you're trying to calculate the proper time, T naught, in order to calculate the time in your frame, we're going to have to divide this distance traveled by the velocity, relative velocity, right? Which happens to be 0.8 c. Now let's put everything back in the equation. This gives you the t. So T naught is going to be equal to x over v, this is t, divided by gamma, right? Now 1.2 times 10 to the power of 8 divided by 0.8 c times, well, let's on a separate note calculate what gamma is. Gamma is 1 over square root of 1 minus 0.8 c squared over c squared. So then when you do algebra, gamma factor is going to be like 1.666. It's going to go on forever. Now we can put 1.666 here, and then when we calculate the proper time, it's going to come out to be 0.3 seconds. Now, in part B, we're asked to calculate the distance from you to her based on the racer's point of view. So then in part B, the proper time, we know that it's 0.3 seconds now. All we need to do is, in order to calculate the distance, is v times t naught, right? Again, 0.8 c times the proper time, 0.3 seconds. So that's going to be equal to 7.2 times 10 to the power of 7 meters. In part C, we're asked actually backwards the same question as part A. Now this time we're asked the time for you at that moment when the time is 0.3 seconds for the racer. So all we need to do is to use the same formula, T naught equals T over the gamma factor. So T here is going to be gamma times T naught. We calculated gamma to be 1.666 times T naught is 0.3 seconds. So you're going to see that what you measure is going to be like 0.5 seconds. So it's pretty different than what the racer measures, right?